Now, good day students, and welcome to the fourth nugget on biomass for energy. The previous nugget concerned plant residues from agriculture and from silviculture. Some people think that agriculture is the only potential source for bioenergy, and some people think that we must clear cut the forests to produce bioenergy. But this is not so. You may be surprised now when we start looking at the biomass resources available in urban areas and from urban areas. Urban areas are not only consumption sites, they also generate biomass in the form of waste. Now, waste in general contains very many different substances. Different fractions of the total waste streams may find different use. You will most probably have some type of waste sorting system in your own region, maybe even in your own household, or maybe at the university or at work. And there may be second-hand stores for clothes or books nearby, so then some waste is already reused. But not all waste produced is environmentally friendly, though it may originate from biomass. So there are a number of legal aspects to avoid environmental harm from such fractions. Now open the Busy Plan Handbook and then go to chapter 1.4. Then open the link to look at some of the legal documents of the European Federation that concern waste management. The most fundamental thing is to separate hazardous waste from non-hazardous. And in 1989 an international convention was agreed upon in Basel to define, regulate and control the handling of hazardous waste. Looking now at chapter 2.4, figure 1, you will clearly see that the total waste produced in society is dominated by mineral waste from mining, from the production of ballast for road and building construction works and the like. However, most often, when the word waste is mentioned, it refers only to household waste. And this is just as stupid as to use the general word energy if what you mean is actually electricity. Things should always be called by their proper names. And now look again at figure 1 in chapter 2.4. The previous nugget focused on vegetal waste and wood waste. So what remains as waste of biological origin is concerned is then paper and cardboard, animal waste, and the part of household waste that can be attributed as biological or organic. Material composed of animal cells, that is, material that consists of fats, proteins and carbohydrates, is easily attacked by microorganisms. There are no cell walls to hinder, and the material is easily digested. And in cooked vegetables have the cell walls denaturized during cooking, and that was what made them soft when cooked. So organic waste, whether it originates from canteens in schools or from town restaurants or from toilets or from food processing factories or from slaughterhouses or from households, is best utilized using a biochemical treatment called anaerobic digestion. Such material is called putrescible and is treated in chapters 1.3 and 2.3 in the handbook. So there is a good reason to separate the waste into such waste that is most easily degradable, like solid but wet food waste and similar organic material, and into such waste that is not easily degradable. The second category contains woody residues, but also part of papers and textiles and cardboard waste that cannot be recirculated and such. Typically, this material may contain a large proportion of cellulose and or of lignin, and then it is not easily degradable. The water content in this category should be less than about 50%, and then this second category is most often called combustibles. A third category can be represented by such substances that can easily undergo a phase change or that can easily be converted into a new product using ambient temperature chemical synthesis. Frying fat, for example, may be liquid when it goes down the drain, but may solidify when cooled in the sewerage. And quite a few fatty acids may oxidize and then solidify, or at least thicken, so as to become a problem. You may remember the London fatberg, a blockage in the London sewage system that made the news worldwide in September 2017. Many of the fatty acids or lipids can be synthesized into fatty acid methyl esters, or FAME, which can be used as a diesel oil substitute in engines. So a common strategy is to separate waste into hazardous waste that must first be separated and treated all by itself. Reusable products can be used again for their original purpose, second-hand clothes, for example, or glass bottles. Recyclable waste can be used as a raw material to produce something new. PET plastic bottles can be used to produce fleece sweaters, just to mention one. But then there are three major fractions that may to a major extent consist of biomass, and those are the organic waste, which by definition should be all biomass. The combustible fraction will often be heavily contaminated by plastic and other fossil-based contaminants, but parts of it may well be clean, solid biofuel. Cooking oils and fats are the third category and may to a great extent be synthesized into diesel fuel substitutes. Now there are two more categories of societal waste that may be used for energy. One is demolition wood. Some of this may be impregnated or painted and will then have to be used only in combustion plants equipped with a very advanced flue gas cleaning. But it will still be a solid biomass-based fuel that is suitable for use in the energy system. And then there is the sewage sludge. A human will produce anything between 100 and 250 grams of dry feces every day. In the wastewater treatment plants will these feces finally become available for anaerobic digestion. And this is a significant resource, as you will see in the homework, and it should not be disregarded. What you should do now is to read chapters 1.3, 2.3, 1.4 and 2.4 in the Busy Plan Handbook, and after that you will be prepared for the homework.